Welcome to Conversations with Plastics News. I'm Joe Pryweller, Conference Director with Plastics News. I'm pleased to have with us today a new Plastics Hall of Fame member, John Beaumont, President of Beaumont Technologies. John's company is a world leader in in-mold control technologies for injection molding and in plastic mold flow and design, and he helps processors mold faster and more competitively.
There you go.
John, we're going to start by talking a little bit about the Plastics Hall of Fame before we get into your company.
All right.
I imagine you were pretty surprised and honored by being a member of the Plastics Hall of Fame. How was the ceremony, and what do you think were some of the contributions that helped you become a Plastics Hall of Fame member?
Yeah, definitely. I was a little surprised by the whole thing. But
Good.
It feels good, right? There's no doubt. It kind of feels good to get that acknowledgement. The event was great, very well organized. It was a lot of fun. In terms of the contributions, it's a little bit hard to kind of put all those pieces together. It's been a lot of years, but I think if I was going to focus into a couple of things that I think were most important to me, that had the highest value to me, is one would be certainly the work I did in helping start up, develop, and mature the plastics engineering technology program at Penn State.
Ah, okay.
Right. So that was 25 years ago. I came out of industry to help start up that program, and at that time I think we had 3 graduates, and now there's probably close to 1,000 graduates out there. So
it's grown a little bit, hasn't it?
It's grown a little bit, and it's a little bit of you feel got that Johnny Appleseed feeling. It's you're planting the seeds out there. And
yeah.
So that would be one element.
Was that area not as big as 25 years ago? Were there not as many people going into that area?
No. I mean, it's gone through waves, right? So early on, it was like I said, 3 students in first class. Programs ramping up, and we went to classes as many as 60, 70, and periodic. Like now, we have a smaller class, but the class behind it goes in waves.
I imagine the education's got more refined and sophisticated over the years too, with those type of programs, right?
Yes, yeah. I mean, definitely. I think it's that blend of activities of understanding plastic materials, part design, mold design, processing, and I've always had that argument that no matter where your job function is in the industry, whether it's any one of those or quality or something, if you don't understand all 4 of them, you're missing some key components. So that was a lot of what that program was built around, is that kind of philosophy.
Terrific.
Yeah. I think the other thing that, if I reflect on the stuff that was accomplished, probably the second most important thing to me anyways, was the discovery of shear-induced melt variations in molds.
Ah, okay.
Right? So that goes back some 15 years or so, but understanding that phenomena, educating the industry. I think it was once felt that, once we'd come up with a reciprocating screw, that now you had control of melt, but now you put it into a mold, and at that time it just wasn't understood that that's creating huge variations as the melt travels through a mold. So back then, simulation couldn't pick up this phenomena. It was totally unknown why all these things are happening when we mold products. Okay. Unknown. It was
so if the plastic is full in the mold, didn't know what happened from there. Right?
Well, right. It was like that gremlin, right? There's just stuff happens, and the position of the moon or something, and the realization now is that, right, what the industry had coined naturally balanced runner is really the source of probably the biggest variable in injection molding today.
Yeah.
So that was neat, and then of course coming up with a solution with a melt rotation technology. So
excellent. Because some control technologies to really understand some of that. Huh?
Is that what's that?
Putting together some real logical control technologies. And
yeah, that's right. I mean, it's good to understand it, but ultimately you need to manage it and be able to solve the problems that are occurring. Yeah.
Excellent. Well, let's talk a little about your company, and that this kind of winds into what we were talking about here with I know you have technology that you develop at Beaumont Technologies in Erie, Pennsylvania, melt flipper. And that's been a big part of your growth, I imagine, with Beaumont and with what you're doing. Maybe just explain a little bit about what that is and then what impact that's had.
Yeah. So that technology spun off, right? I discovered this phenomenon, and now it was how do you deal with this phenomenon, and that was the problem. And so we did come up with a means to deal with it, and I kind of relate to it as having discovered sliced bread. I mean, once you understood the physics, and I came up with a solution, it was one of those aha moments, and the solution becomes pretty simple and elegant. And we first introduced that, actually, I think it was 5 NPEs ago. So,
wow, okay.
So our first introduction,
like
the industry
15 years
had,
ago or so, huh?
Yeah, I mean, it was, 15 years ago was we came in, I'd done some publications on the problem, but we hadn't had a solution. So we came up with a solution. I bought my patents from the university, started up the company. We showed up at NPE in some back corner, and there were, I think, 3 of us, and I brought a student along to help us with it.
Wow.
And we figured, we won't see too many people, but the 4 of us could never leave our booth. It was just a lot of interest. And now over those 15 years, we've got thousands of applications pretty much worldwide on every continent, every major industry out there. It's becoming more and more of an industry standard, particularly in high precision molders, that we're still, that it's becoming more of a standard that we're finding.
What was your aha moment? What was a problem that you felt needed to be fixed with something like this?
Yeah, well, I mean, the story is a little bit long, and I may not get into that, but
yeah,
basically...
the concise version, I guess, if you can.
Yeah, this was something we've been working on for a long time, and we're thinking, geez, how do you mix this? How do you do that? And you just couldn't do it without creating its own problems. And it was one of those long drives back from Massachusetts to Erie, Pennsylvania during the holidays, visiting family, and driving on the road for like 7, 8 hours, just gazing in and into the sunset, and finally it just dawned on me we didn't need to get rid of the problem, was managing it. And I concepted some stuff on the drive home, got home, brought up my son's Play-Doh, rolled up some stuff and started forming it in Play-Doh, and conceptually there was the concept.
From Play-Doh, huh?
Yeah.
Okay.
So that was the beginning.
Wow.
Yeah.
That's great credit, Play-Doh, for that. They never did. Yeah, they never gave any royalties or anything from use of Play-Doh for this.
What's that all about?
Wow, that's excellent. I know on your shirt you have the AIM Institute.
Yeah.
And I'm sure a lot of people here don't realize what that is since it's new.
Yep.
But I know you had a kickoff for yesterday. Was it at MPE?
That's right. Yep.
But I'm sure it's of interest to a lot of people here. What is the AIM Institute?
So the AIM Institute, really, it's the American Injection Molding Institute. So this is a new entity that we're pretty excited about. And I think to lay a foundation, I think to understand what I'm trying to do with the AIM Institute, what we're looking to do, is...
First of all, what's AIM stand for?
Well, American Injection Molding Institute.
Okay.
Yeah. So AIM, keep it short.
Right.
So when you look at the plastics industry, I always try to get people to focus in and understand how complex this industry is. And I'll ask people, how old do you think this industry is? When was the first patent in injection molding? And people, I had someone respond yesterday, say, well, about 50 years. And I go, no, it's about 150 years.
Wow.
Hyatt developed patent of the first molding machine 8 years after the Civil War.
Jeez.
So this is not a new industry.
Not by any means.
Right? So it's not new anymore. And when you look at that and you say, okay, we've been around for a long time, and we can do a lot of things better. We see a lot of nifty technology here, and we see molds built to tenths of thousandths of tolerances of microns.
Become very precise and very sophisticated.
Precise. And despite all that, after 150 years, every single mold that started up, people expect it to fail. Every mold.
Huh.
So, right, the beginning is you rush to get that mold built, you do everything you can, you put it in the press, you do everything right, and now you start going back to the tool shop, modifying, back to the tool shop, modifying, bring it back, and you go, it's the beginning of this iteration of painful, time-consuming, costly. And the point is, in getting people to reflect on that, is that our industry is extremely complex. And people say, oh yeah, I know that. Do you really understand how complicated this is? Why is this problem still occurring after 150 years? We have injection molding simulation, we have all this years of experience, we have new technologies, And why is this the standard, the norm, the expected norm?
Why are we having the same problems we've had for years or generations in some cases, right?
They're still there.
Yeah.
And as I said, I mean, we're dealing with what I would argue to be the most complex part formation process on the planet. And people go, oh, wait a minute, there's a lot more complicated things. But stop and think about it. We're dealing with a pseudoplastic, non-Newtonian fluid, right? Molten fluid, flowing through a cold mold, simultaneously flowing and freezing,
wow.
while it's all these stresses under pressures of 10, 20, 30, 40,000 psi, and the effects on that and the morphology of the plastic, orientation effects, how it sets up shrinkage, warpage, and all this sort of thing. We still don't have the science to even measure many of the things we do.
Really?
The simple thing, think of a simple thing like, what's the melt temperature in a mold? No one knows how to measure that today.
Huh. There's still no precise measurement for that,
There's no precise measurement to measure that, or even coming out of a molding machine, yet we put a man on the moon back in the 60s,
right.
We had artificial hearts in the 60s, and what's going on? So the way I look at it is, one, we got to acknowledge how complicated our industry is. Stop trying to apply arts and techniques and legacy methods to solve problems. And
shouldn't be a black art, it should be a science, right?
Should be a science. And we use the word science, but it's pseudoscience, it's legacy, hand-me-down stuff. And so I'm getting to the AIM Institute.
Sure, that's
saying,
fine.
The point is that in looking at that, if you look at the way people enter our plastics industry, and particularly injection molding, you don't see young kids, they're not being... Nobody says, I'm going to be in injection molding when I grow up, right?
Right.
Or even plastics. What happens is, if they go into college, they may be electrical engineering, mechanical engineering, civil engineering, biomedical.
Sure, some of the basics.
And that's our industry, right?
Right.
So now they come into plastics, and how do they learn? Where do they get the education? Well, it's kind of really through osmosis, right? It's from the guy to the left of them and the guy on the right of them who aren't educators. They're not interested in educating them because they're busy. They're trying to do their job. So you're kind of learning through osmosis, and people go, well, I learned by on-the-job training. I learned how to do this. Well, okay.
Yeah, I mean, you might learn from others before you, or just doing it, right? Yeah.
And where they learn. So
right.
That's that legacy, hand-me-down art method that is propagated through this industry, and I think it's stunted the growth of this industry.
Yeah.
So the AIM Institute, the intent of that is to take a higher level education, make it accessible to people, practicing professionals that are in the industry. And we actually launched our first class 3 weeks ago, and in the certification portion of this. So there are various programs within it. And in that, we've actually got 2 plastics engineers that have degrees in plastics, and they're going through it and realizing they're learning new things. And part of that is, I think it was an interesting comment Mike Sepe made yesterday, and he said, when you're in college, even if you had a plastics degree, you were getting answers to questions you didn't even know how to ask yet. Right?
It's that unrefined that people don't even know what questions to ask with this industry.
You didn't know the value in what you were learning.
Right.
And how many people lament over the fact, geez, I wish I could go back to college now, or I wish I could get that foundational.
Sure. Instead of just moving along the road we've been on and not considering there might be a better way to do some of this, right?
Right. So we're trying to deliver that higher level education, not just training, but education. And there's some excellent training in the industries, people doing some excellent work, but this is education. We're looking at, and the difference may sound subtle, but it's very distinct. Education is intended to provide that higher level understanding where you can develop critical thinking.
Right.
And through critical thinking is where you can really go beyond the sum of what's delivered. I can deliver this content, but I want you to be able to use that to be creative on your own, create original thought, and to be innovative, right? That comes from critical thinking. And that's the sort of thing we're trying to accomplish in the program.
Right, so you're looking at, so this is for practicing professionals in the plastics industry who want to learn how to do this? It's not for, in other words, are people in college or people just starting the profession necessarily, but
well,
it's for...
It could be starting the profession. I mean, it could be. So I think the people appreciate it the most, we think, would be someone who's had a little bit of experience, right?
Right.
But in the current program, we have engineers and we have non-engineers in the program, technician level, but they're people to come in, they take a qualification exam, and then we discuss with them online or their management the results of that and make recommendations, and if they want to continue, and we might say, well, you're no problem, come right in. You may need a little orientation, maybe you should do this and this and this to get ready for the program. But it can be all levels of people. And when I look at our mission statement, a summary or compressed version of the mission statement is, of the American Injection Molding Institute, is to advance the injection molding industry through providing high-level education to practicing professionals. And when we say practicing professionals, it's not just molders. It can be molders, but it's also product designers, developers, R&D, you know, it's the whole breadth, quality. All these people need to understand these different components of what make a successful plastic part.
Terrific. Well, let me finish by asking you a little bit what you're showing at MP this year, or what you're finding is on the MP floor that's of interest to the industry.
Yeah, I mean, a couple of things. One of the things we got going at the booth is the first time we brought in Plastic Sodic provided us an injection molding machine, and we're running live demos showing with and without melt flipper, right? That's the melt rotation technology. And so people can see no smoke or mirrors the impact of this. And we're doing pressure traces so they can see all the filling and the variations and so on. So that we're going through on regular demos in the booth. New technologies, we're introducing a couple of new things. Software-oriented stuff. One is injection mold diagnostics we call 5-step process. That's cloud-based now. We've had that for a number of years, but we had people in Asia in different platforms say they're working Apple computers, and rather than continually upgrading, we put everything cloud-based so they can come in and access it there.
Good.
And probably the thing I'm most interested there is what we call thermoflow. So thermoflow is a brand new way of characterizing the injection moldability of plastics, and I call it a moldometer, right? Because there's no other thing to describe it.
Right.
So we use a moldometer,
moldometer. Okay.
Moldometer, yeah. So from there we do about 150 different tests on a given polymer to map how it molds. But the software we're introducing can take that and extrapolate a lot of the conditions, how it's going to behave under different geometries, different wall thicknesses. So it's not a flow simulation. It's not a mold flow sort of thing. But it actually augments that. Makes comparing, I mean, I can compare up to 4 materials simultaneously and map how the pressure is affected by flow rates, temperatures, thicknesses. So it gives a tremendous amount of information in a very easy to digest format.
Great.
So that's a new animal we got over there.
Excellent.
Yeah.
Well, great, John. Best of luck with booth visitors to the show, and congratulations again on. Where's your booth, by the way, just so I can tell people?
Where's our booth?
Oh, it's over that way somewhere. Anyway, it's over that way in the corner.
Yeah, it's along the back aisle on the main West Hall. Yeah.
Well, thank you. Congratulations on your Plastic Hall of Fame Award, and for sitting with us for Conversations with Plastics News. And great to have you.
All right.
Good to see you. Thanks, John.